Okay. Basically, in the research, we deal with the three kinds of data set: the cross-section data, time series data, and the panel data. So it is important to understand all type of data set, that what is the difference between the different type of data set. And so I am starting from the very basic, so don't worry about that. Um, you can see in this slide that there are three types of data set: cross-sectional data, time series data, and panel data. And there is a beautiful example I quote here, that if your degree of measurement is 1 day, then your life for today is cross-sectional data. Your life for past 10 days is time series, and the life of many person, including you and your family, over past 10 days is panel data. So in the first case, we are having the cross-sectional data, and whenever we analyze the data that belong to a particular period of time or moment of time. For example, all the data which you collect from the questionnaire is cross-sectional data, because you collect the data for a short period of time or a short duration of time. When you collect the data of a short period of time or a short duration of time, this data is called cross-sectional data, and the dimension is known as space dimension. Means we only collect the data from the different units, right? So, or in panel context, we call them cross-sectional units. Like for example, if I ask you the price of different shares of today, if I ask you that give me the information of the different companies, their share price, their P ratio, right, the returns. So this is simply the cross-section data. You collect the data of many people from the or customers with the help of questionnaire. This is also the cross-section data. Now, a second type of data is time series data. The time series data is simply when you collect the data over a period of time in chronological order. That data is known as time series data. And panel data have two things. When you collect the data of many people, many cross-section units for many time periods, this data is known as panel data. But I'm telling you that this is the definition of given in most of the books. But from the my experience, I further modified this definition. Now I'm showing you the modified definition of the different type of data set. So this is my definition on the basis of my experience with the research. I define in different way. Like for example, I divide the component in three types. This is time component, this is the cross-sectional units, and this is the variables. So there are three components of the data. One is the time component. Unit means from where you are collecting the data. Means suppose you are collecting the data from patients or from the companies or from the customers. So these are the units. And variables means you are collecting the data for many variables. So in cross-sectional data, we define that time component is not there, because we are not, we want to, uh, we are collecting the data of a short period of time. Here, the objective is not to analyze the behavior of the variables for the time or during the time. So time component in cross-sectional data is absent. But we are collecting the data from many units, many cross-sectional units, many customers, many respondents, many companies, and we are collecting the data of many variables. So this is the case of cross-sectional data. In time series data, the time component is one of the most important component. Like if you collect the data in a chronological order, and the data may be daily, weekly, monthly, quarterly, annually. So this facility, this feature is there in the time series data, that the data is collected in a chronological order, and the order may be daily, weekly, monthly, quarterly, annually. And if we talk about the units or variables, any one feature may be there. Both the two feature cannot be there in the time series. For example, either you are having the data of one unit with one variable, one unit many variable, or many unit with one variable. Okay, now I'm giving you one example. Suppose I want to collect the data of GDP of India from last 20 years. So here we are having only one country, that is India, and we are having one variable, that is GDP. So we are collecting the data of GDP from the last 20 years of India. So we are collecting from one country and one variable. Or time is 20 years. So this is data is also time series data. One unit with many variable. For example, if I collect the data of GDP, money supply, or interest rate, right, or exchange rate of India from last 20 years, this data is also known as time series data, because one unit means we are collecting the data from India only, but we are collecting the data of many variables, like we are collecting the data of GDP, money supply, interest rate, right, and any other variable like exchange rate. So this is also a time series. Similarly, we can have also many units with one variable. Okay, so what is the example of many units with one variable? For example, if I want to collect the data of GDP of Brazil, Russia, China, India, all the BRICS countries, if I collect the data of GDP, only GDP from 4 countries or from 10 countries, then this data is also known as time series data, right? So there is a confusion between the time series data and the panel data in this context. So that's why I mentioned the 3 cases, that if 3 cases are there, if these 3 cases are there, we cannot call it panel data, we call it only time series data. The panel data have all the 3 features. For example, the panel data must have the multiple time series, multiple units, and many variables, right? So if 3 properties are there in the data, then we can call it panel data. Okay, now I'm giving you many examples of panel data, because in finance and economics the panel data is so common that uh, but the problem is that I have found in my life many people are working with the panel data, but they don't know that this data is a panel data, so they are considering this data as a cross section data. Okay, I'm giving you some examples. Suppose I want to check that whether the FDI which comes in the different countries influences their GDP or not, right? So I wrote one paper just 10 years back, where we have seen that uh, how foreign direct investment influences the GDP of different countries. So we collected the data of FDI of BRICS countries, and then we collected the data of GDP, money supply, interest rate, and per capita income, like that. And we want to see the impact of that which country is more efficient in analyzing the FDI in improving their GDP or money supply or per capita income, like that. So in this case, we are collecting the data of 4 countries: India, BRICS countries, Brazil, India, China, Russia, right? So there are many units, and time component, we collected the data of 15 years, so it is a time component. And because we are having the different variables, like FDI is one variable, GDP is another variable, uh, and then export may be another variable. So we are having the different variables and different units, different time periods. So this is a panel data. And most of the people in finance, they want to see the impact of debt equity ratio on the ROI of the company, yeah, or the dividend distribution or dividend payout ratio of the company. So whenever you took this kind of research, then you have to collect the data of debt equity ratio of, let's say you decided to take the data of Nifty 50 companies. So in this case, you will collect the data of 50 companies, so it means 50 units, and you will collect the data of many variables like debt equity ratio, return on equity, or market capitalization. So there are many variables in the data set, and we decided to take the data because it is annual data. So it may be we are having 10 years data set, 20 years data set. So when all the three features are there, so I just repeat, this point is important. If you have all the three components in the data, then only you can say it is a panel data. So first component is that you must have the data for many years or for many time periods and collect it in a chronological order. You have the data from multiple cross-sectional units, like many companies, many countries, many states. And third property there must be at least one dependent variable and one independent variable. So this is the condition of panel data. If all the conditions are fulfilled, then we can say the data is a panel data. So I hope it is clear. The panel data must have all the three properties. Otherwise, you can't say that it is a panel data. Uh, and I'm telling you from my long experience with the research and consulting that panel data must have all the three features, that multiple time series. Time series means you must have the time component in the data, multiple cross-section units, and then the multiple variables. Okay. So I think now it is clear that what is the panel data. Now let's come to the other branches of the panel data. So what actually we want to see in the panel data? What is the objective of panel data? So what we actually want to do with the panel data? This is the this we have to understand. So in most of the cases, I have seen two major objectives of the panel data. There are basically two different objectives in the panel data analysis. The first objective is that uh, testing of the theory. The common objective is the testing of the theory. For example, suppose we want to analyze the impact of the capital structure on the profitability of the company, the impact of corporate governance on the dividend payout ratio of the company, right? So these are the topics. The objective is to check the theory. So whether the theory is applicable on the companies or not, right? And sometimes we want to analyze the relationship between endogenous variables and the exogenous variables, between the different variables, different countries, or the different, like in economics, the researcher want to analyze, find out the relationship between GDP, export, exchange rate, and different variables. So this is the objective. Uh, One of the major objective of panel data analysis, that to find out the relationship between different variables as per the theory or as per the literature review. The second objective I have seen in practical. Practical means companies. So industry are using the panel data not for the testing of the theories. They are using the panel data for analyzing the efficiency of the companies. Like I'm giving you one example. Suppose there are four pharmaceutical companies. Let's call them A, B, C, D. There are four pharmaceutical companies, and every company is utilizing the expenditure on advertisement, expenditure on the R&D, right? So you understand what is the meaning of R&D and advertisement. And everybody know that if you spend more on the R&D, your profitability will increase. If you spend more on the advertisement, your profitability or the sales will also increase. Now I am asking you, is it possible that if every company increases the same budget for advertisement and R&D, so can you say the sales of each company will increase equally? Now think on that. So I am also giving you example in another way. Suppose there are four members in your family, and every member is consuming the equal food. So is it possible that the increase in weight for all the four members are equal? So answer is very simple, that it is not possible that all the four members have equal increase in weight if they take the equal food. because this is because of the heterogeneity between the different cross-sectional units. Now listen very carefully what I'm saying. uh, I am saying that all the companies are not same, all the companies are different, right? For example, if I ask you, if FDI, this FDI is a very simple concept, the foreign direct investment. If foreign direct investment comes in India, if foreign direct investment comes in China, Russia, or any Brazil, so do you think the efficiency of each country is equal in utilizing the FDI in increasing their exports? Is it equal? Is it possible that the efficiency of all the companies are equal? So you can answer very easily that the efficiency of all the countries cannot be equal. It may be possible that some country is more efficient in uh, in uh, converting the FDI into the exports. Some country may be more efficient, some country may be less efficient. So sometimes we want to analyze the efficiency of the companies and on the basis of their heterogeneity, right? So this is also the objective of the panel data analysis, that which company is more efficient in utilizing the input variables on the output variables, right? So I have seen these two type of projects, one on the basis of the theory and another on the basis of the comparison between the cross sectional units. And uh, so one thing which is common here, that concept is called heterogeneity. So what is heterogeneity actually? Because the problem is that because we are taking the data from many units, so in most of the cases it is not possible that all the companies are exactly same. Can you say that all the companies are same, all the companies have the same features? No. So in that case, you have to take some control variables also in the models. Like suppose you capture the firm size or the age of the firm, some control variables you want to keep to find out, or to find out the exact relationship between the exogenous variable and the endogenous variable. So endogenous simply means dependent variable, and exogenous variable simply means independent variable. And we assume, sometimes we assume that the relationship between dependent variable and independent variable is same for all the companies, and sometimes we assume that the relationship between endogenous variable and exogenous variable is different for different companies, right? So there are different assumptions, there are different models which you can deal to analyze the panel data. Now there are different names, and I'm telling you that there's a lot of confusion in the research scholars, that what is pooled data, what is cross sectional data, what is panel data, how pooled data and panel data are different, what is longitudinal data, right? So there are different confusions actually. So let me explain all the different types. Here I am going to explain pooled data. So I will explain you these type of data set, and I have a separate slide to explain the difference between the pooled data and the panel data. And the analysis of this kind of data, panel data, is known as panel data regression modeling. Okay, now I'm going to make you clear the difference between different kinds of data set, like longitudinal data and panel data, then micro data, macro data, and all. This is one of the examples to show that how the panel data is working. Like for example, if you want to analyze the effect of advertisement sales on sales, advertisement is the independent variable, sales is the dependent variable, but we are taking the data of different companies and of many years. So two variables, many companies, many years means panel data. Suppose we want to see the effect of qualification on income with different individuals and time, because in psychology they are using the longitudinal studies. So sometimes we want to see the effect of these variables in especially psychology and even medical science. This panel data is quite popular, but they call it pool data or longitudinal data. In finance and economics, we call it panel data. So what is the difference between all these kind of data set? So I will okay. So first of all, this is the difference. But before explaining this difference, I want to tell you one thing. There are four major type of data set. So first of all, we want to understand what is the balanced panel, unbalanced panel, short panel, and long panel, and then we will go to this slide that what is the difference between pooled or longitudinal or panel data. So let me explain you first. What is the balanced panel data? Now, one thing which I want to tell you here, the panel data. In panel data, we are having two things very common, that I and T. I and T, right? Here I is representing representation for the cross section, and T is representation of the time period, and we are having the Y variable Y and X. Y is representing the dependent variable, and X is representing the independent variable. Suppose we are having the data of 20 companies, so we will write 1 dash, then 2 dash, 3 dash, right? So 1 means we are having the data of first company, time period 1, 2, 3, and so on, then the value of Y and the value of X. So this portion indicate you the data of first company for 10 years for Y value and X value. Then we will mention the data of company number 2 for all the periods and for the Y values and the X values. Similarly, we keep it for third company for many time periods, for the value of Y, for the value of X, right? In this way, we represent the panel data. Now, the point is that suppose you are having the data of 10 years for each cross section. If the time period for each cross section are equal, this data is known as balanced panel. So we can write the balanced panel as when the time period of first equal to time period of second equal to the time period of the third, and so on. If we are having the all the data for all the years for all the companies, then this is called balanced panel. Similarly, we are having unbalanced panel. Unbalanced panel means the time period of first company is not equal to time period of second company, or like that. So for example, in this case, you can see that we are having the time 2001 to 2003, and we are having 2001 to 2003 for first person as well as second person. So this is the example of balanced panel. But in this case, we are having the only 2 year data for first person, 3 years data for second person. So this is unbalanced panel, because time period in first case is 2 year, and for second person it is 3 years. So I hope it is clear now. If it is clear, say yes in the chat box. Okay. So now you say that yes, the difference between, I know it is a very basic thing, but clarity is must. Okay. After that, we are having the short panel and the long panel. Okay. Uh, the the short panel means, so here I'm explaining you the concept of I and T. I means cross section. Cross section. Cross section means the respondents or the patients or the respondents or the patients or the countries, right? So this is I, from of which you are collecting the data. Now T means the time or the year, right? Time. It may be monthly, it may be yearly. Most of the time it is yearly. So year 1, 2, 3, 4, and so on. So I hope you understand what is the meaning of I and T now. Now the question is that when we are having this kind of data, and this is I and this is year, right? we are having two possibilities when I is greater than t, when I is less than t, right? For example, if we are having the data of 20 companies and 40 years, so 20 companies and 40 years. So which kind of data it is? It is a short panel or long panel? It is a short panel or long panel? Yeah, very right. Because here I is greater than T, right? I is greater than, what is I? I is 20 and T is 40. So this is long panel. It is not a short panel. Actually, I write here wrong. Here short means T is less. So T is less than I and T is greater than I. So now I write the same condition in front of the, and again I am giving you another condition that in one paper we collected the data of 200 companies, 200 companies, and for the 10-year period, 10-year period, and we want to see the effect of, suppose, debt equity on, effect of debt equity on, let's say, market capitalization, right? So debt equity or and ROE. So which kind of data it is? It is which kind of data it is? It is panel. It is long panel or short panel. So it is a short panel because time period is less than number of companies. So in this way, we can define the short panel and the long panel. In short panel, time period is less than the number of cross sections. In long panel, time period is more than the cross sections. So in this way, we can define the short panel and long panel. So I hope you have clarity between the all the four, and so that we can move further. Okay. Now, again, I repeat. In I will normally in the FDP, I will finish my lecture first, and then I open the discussion for forum for discussion. So let me finish the topic first, and then I will take all the queries. So meanwhile, I'm looking at the chat box in order to find out that majority is understanding or not. And for topic for discussion, we will have a lot of time. And so first of all, tell me, is the clarity between balanced, unbalanced, short, and long is clear or not? Yeah. So most of you are saying yes. So let me finish the topic first, and then I will take your queries. After that, let me discuss the pooled cross section and panel data. What is the difference between pooled cross section and the panel data? Actually, what happens? Suppose, let me explain you the example with the help of example. One of the doctor decided to find out the impact of the age and the BMI on the blood pressure, right? So here there are two dependent variables: the age, and second is the BMI, age and the BMI, and the impact is seen on the blood pressure. Now, for that, the the patient decided to collect the data for 50 patients, and he decided that uh, in the month of January I will measure the BMI and the age of the different persons, and will also check their hypertension, means blood pressure, and I will continue for the next at least 20 years or 30 years, right? So in this case, I'm asking you two things. Just listen carefully. So I repeat the example. The doctor decided that he will collect the data of 50 patients, for example, 50 patients, and he will collect the data for next 20 years, and he will collect the data for three variables: the BMI is body mass index, and the second variable is age, and the third variable is the hypertension, that is the blood pressure. and he also decided that he will collect the data in the month of January. Now I'm asking you two things. Is it possible that all the 50 people he decided will survive for the next 20 years? Right? You can tell me. Is it possible that all the 50 patients will survive in the next 20 years? No, not possible. Right? Second question is it possible that if somebody is not available on 1st January, he may collect the data on 10th January? For one patient, he got the data in 20 January. For third patient, he got the data in 15th January. Right? It may be possible. Right? So, do you think if he collect the data on 1st January, not and next year he will collect the data on 10th January, or in third year he will collect the data on 20th January, will this make a difference in the weight on blood pressure? Right? So, will it? No. No. Why no? Because if your BMI is whatever your BMI is today, it is not possible that this BMI will change in next 3 days. Right? It is not possible. So whether the doctor collect the data on 1st January or 7th January, there will be no change in the blood pressure or in the BMI or in the age. Right? There will be no change. So right. So this kind of data. Okay, this kind of data, age may changes by only 2 days or 3 days. That is not a problem because the age is measured in years, right? So, in this case, the uh, there will be no change in the age. Okay, um, in this case, this kind of data is known as pooled data or longitudinal data. So, this kind of data is known as longitudinal data. And in panel data, the panel data is panel data. The condition is that all the persons should be there, and you collected the data from the past, not from the future. Number one, all the data you collected should belong to the past. And if any company is not is maybe liquidated or the data is not available, you have to remove the data of that company. So it is required that in panel data, all the data is collected for exactly the same companies. You cannot change the companies, and the time period should be same. So when your cross-section unit should be same, time period should be same, then this is known as panel data. But in longitudinal problem is that suppose Mr. X and Y and Z will die after 5 years. So you have to replace these 3% with similar persons who are having the same BMI, same age, right? So in longitudinal data, you can change the cross-section units, but in panel data, you cannot change the cross-section units. So I hope you have understanding between the pooled data and the panel data. Now you can see the difference between the two. In pooled cross-section, randomly sampled cross-section of individuals at different point in time, pooling makes sense if cross-sections are randomly sampled. Time dummy variables can be used to capture the structural change over the time period. Observations across different time periods shows for policy analysis. Pooled cross-section can be useful for evaluating the impact of certain event on policy implications. In this case, the cross-sectional units are not important. The important is the concept. However, in panel data, the cross section is very important. Observe cross section of the same individual at different point of time. So here individuals are same or cross section units are same. In panel data, the heterogeneity is very important. In pool data, heterogeneity is not important. We assume that all the people are same. The impact of the independent variables on the dependent variables are same. However, in panel data, this heterogeneity play a very important role. And based on this heterogeneity, you have to decide the models, right? Okay. So I hope now you have some sense of the difference between the pooled data and longitudinal data are the same thing. And panel data is different thing. Panel data is different from pooled data or the longitudinal data. Now, I hope you have a clear difference between the two. In pooled, you can change the individual. In pooled, you can even change the time period also. But in panel data, you cannot change the cross-section units and the time period is fixed. Okay, so let me proceed. This is the property of the panel data. Number one, basically what we are doing in panel data. Listen, so we collected the information of individual in behavior, both across individual and over time. So we want to know that how the variables are changing over the time period, how the behavior of the variables is changing over the individuals. So two things we have to find out: the effect in the cross section space and the time space. So let me give you the example. So can I say the effect of one variable on another variable is same for all the companies? Like for example, can I say all the companies are equally efficient in converting the debt equity ratio in the shareholders' wealth? Is it possible? It is same. Is it same for all the companies? Maybe no. Some companies are more efficient. Some companies are less efficient. So this is the in this case we are analyzing the behavior of the relationship between the variables across the individuals. Sometimes we want to see that how this relationship will change across the time period. Can we say this relationship improves in the during the time period? So there are two type of effects in panel data. One is called cross section effect and second is called time effect. So in cross-section effect means whether the relationship between the dependent variable and independent variable is same for all the individuals. And in time effect, we want to see whether the relationship between the dependent and independent variable will be same through time or it will change with time. So we can see all these things, and there the number of observations, if you want to calculate the number of observations, you just multiply the number of observations multiplied by the time period. If you are collecting the data of 20 years of 10 companies, so it means the number of observation is 10 multiplied by 20, that is called 200 observations. In panel data, this homogeneity and heterogeneity is very important. So we will discuss a lot about the homogeneity and heterogeneity, and then the correlation over time for a given individual. Okay. So in this point, we just say that the relationship between the different variables may change with time and may change with the different individuals. So, okay. Now, some technical concept. With this concept is very important. Please listen carefully. And so, just give me 1 minute, and I. This is a complicated topic, so just wait for 1 minute. Okay. Now, this point is very, very important. I'm telling you, because before that we are discussing only the theory, and I will answer your questions related to that also. So that will give more clarity. But this point, listen very carefully. There are three types of variables in the panel data. One is which is changing with time and the cross section. Second variable which is constant throughout the cross section, and third which is common or which is constant with time. So there are three type of variables. Number one, the variable which is different for different variables, sorry, which is different for different time and the cross section. For example, if I ask you that can I say the market cap of all the 20 or the 50 companies which are there in the Nifty are same? Can I say the market company of the 50 companies are same? No. Answer is no. Can I say it will be same with time also? can I say the market cap of these 50 companies will be same in next 20 years? No. So it means market cap is a variable which is different for the different variable, different cross sections, and this variable will also be different in the next 20 years. So this kind of variables are known as time varying and the cross section varying variables. Okay. Second is time invariant variables. For example, do you think the gender of the people will change with time? Answer is no. So gender is known as time invariant variable, right? So there are many variables which will not change with time. For example, the difference, the physical distance between the India and Japan or the Dubai is will be constant, right? So some variable will not change. For example, education. If you are PhD, I think after 20 years you will be PhD only. So in some cases, this is just an example. In some cases, the variable may be same for many years. These variables are known as time invariant variables. For example, if you belong to India, you still belong to India 20 years after 20 years also. So these variables are known as time invariant variables. The second kind of variables are known as individual invariant variables. Like for example, uh, we are collecting the data of India, China, Brazil, and Russia, or if we take the data of, let's say, if we collect the data of different states in India, we collect the data of the production in Uttar Pradesh, production in Delhi, production in Punjab, right? So one of the variable which we consider is GDP. GDP is GDP of India is same for all the variables. And the another example which is very simple to understand, that if you are collecting the data of let's say 20 agriculture fields, it may be possible that all the 20 agricultural fields are using the same fertilizer. So in this case, we can say the fertilizer is same for all the 20 agriculture fields. So this variable, this agriculture, this fertilizer is same for all the agriculture fields. So in this case, this is called individual invariant variable. Individual invariant variable. Now, of why these variables are important, right? I'm telling you that uh, in the panel data, there are different kinds of effects like fixed effects, random effects, between effects, within effects. So if we have clarity on these type of variables, we can decide that which kind of effect we can incorporate for which different kind of variables. So I hope you have clarity on what different kind of variables we can incorporate in the uh, panel data. Okay. So the last one, individual invariant, means if you are collecting the data of 20 agriculture field, it may be possible, that the fertilizer, the amount of fertilizer is same for all the fields. The fertilizer may be same, or the type of fertilizer may be same for all the 20 agriculture field, right? So this may be individual invariant variables. Okay. So I think if you read all the definition with your common sense, it will be clear. Okay. Now let me move to the another part, because what will happen on the there are three type of variations in the variables. There are three type of variables. There are three type of variations in the variables. One is called total variation. Second is called between variation, and third type of variation is known as within variation. So now I am showing you all the type of variations with the help of one example, and after that I will ask you one question. Let me show you the example. Just see this example carefully. because this example will make all clear. In this example, I will give more time to this example because this example is important and will make you many things clear. There are three individuals. Suppose this is individual one. This is individual. Individual means company or person or country. There are three individual, and these individual is represented by the term called I. And this is the time period. So we are having a 4-year data set. 4-year data set. 1, 2, 3, 4 means 4-year data set. So in this case, this I equal to 3 and time is equal to 4. So in this panel data, we are having 3 cross section units, 1, 2, 3, and there are 4 time periods, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, right? And the value of any one variable, xit, is any variable you can assume. This is one of the variable, and the value of this variable is that it means the value of x on first year for the person A is 9. So these are the observations of x. This is the observations of second person, and this is the observation for third person. Okay. Now this is the data which we have. After that, there's only the calculation. So up to this, we are having the data set, right? Now see very clearly. So first of all, we find out the mean of every individual. The mean of 9, 10, 11, 10 is this. So this is called individual mean. Individual mean. The mean of the first person is 10. The mean of the second person is 20. So 20 plus 25 plus 20 upon 15 divided by 4 is 20. The mean of third person is 30. So this is called individual mean, or this is called group mean. After that we calculate the overall mean, means the mean of the total. So let me show you this. The mean of the total is 20. So this value is same for everybody. 20, 20, 20, 20, 20 and 20. So this mean is 20. So this is individual mean and this is grand mean. Individual mean, grand mean. Individual mean, grand mean. So there are two type of mean. This is individual mean of the group, and grand mean means group the mean of all taken together. Now I am calculating three differences. Difference number 1, difference number 2, difference number 3. So see these difference carefully. Forget this part. This is I'm not going to discuss now. Now here we are taking individual observations minus grand mean, means 9 minus 20. So let me make it clear. This is the first case. Means 9 minus 20, 10 minus 20, 11 minus 20, 10 minus 20. Similarly for all. So this is called total deviation, right? So this is called total because we are calculating the difference from the total. So how much each value is different from the grand mean. So this is called total, right? So we are comparing with the total grand mean. In this case, we are calculating the mean of the group mean minus grand mean, right? In this case, we are calculating the difference between the group mean and the grand mean. So this is called between. This is total and this is between, and this third case is known as within. Within means 9 minus 10, 10 minus 10, 11 minus 10, 10 minus 10. Okay, now I am showing you all these things because I want to ask you one thing. Number one. Number one. Uh, Imagine the properties of total, between, and within of three type of variables. One is time invariant, cross section invariant, and total invariant. So there are three type of variables I have discussed, and tell me what the three variables have the property of related to total variance, between variance, and within variance. So I am giving you 2 minutes to think on this, and we'll wait for your answer. Uh, okay. Suppose I'm asking you one thing. Suppose you are taking one variable, and that variable is same with all the time. That variable is invariant with time. So which kind of variance will be zero for time invariant variables? Which, I am asking you, which variable, which kind of variance is zero for the variable which is same with the time? Yeah, Rajesh Gupta is giving me bilkul right answer. Karishma is also giving you right answer, that any variable which is same with time will have within variance equal to zero. So now why I'm telling you how this concept is important, because suppose there is, I'm giving you one example. There is a model called gravity model, and in gravity model, this model is very popular in economics for international trade. And this model say that the international trade between the two countries depends upon their size and the distance between them, right? Okay, let me explain you some of the examples now, so that you can understand why I'm discussing all these things. Okay, so model number one, the international trade, IT means international trade, is equal to beta plus the GDP of the country plus beta 2 is the distance between the country. Now the problem is that the international trade, right? The trade between the countries changes with time, and also different for different countries, right? GDP of different countries are different, also different with time. But distance between two countries is always same with time. Distance is a time invariant variable, right? This variable is a time invariant variable. So in this variable, within variance is zero. Within variance is zero, right? I hope you understand this. So if you cannot use this kind of variable in within effect model, within fixed effect model. So there is a concept called within fixed effect model. So whenever you want to apply within fixed effect model, you cannot take these kind of variables in the model, right? So when I will discuss this within effect model, I will tell you, because this variable is time invariant, so you cannot include this kind of variable in within fixed effect model. I hope you are getting the sense of why I am explaining you all these things. Similarly, I will when there is one variable which is same for all the countries. Like for example, we have the data. We are collecting the data from India. We are collecting the data from China, and suppose we are collecting the data for let's say some other country, Russia, right? And we take one variable that is called Dolex. Dolex is the exchange rate of dollar versus all global currencies, right? Versus all global currencies. Now, the value of $X is same for India, it is same for China, it is same for Russia, right? So when you have one of the variables like $X, this is representing the exchange rate, and for 1 year, this value is same for all the countries. So if you have this kind of variable, this variable is called individual invariant variable. This variable cannot be incorporated in the model called between fixed effect model. So there is a model called between fixed effect model. So we cannot take this kind of variable in between fixed effect model. So that's why I'm explaining you. Please think on it, that what is time invariant variable, what is individual invariant variable, and what is the changing variable. so I explained you the three concepts, that is called overall deviation, between deviation, and within deviation. Whenever we are going to apply the panel data, panel modeling, we should know which variable is constant with time, which variable is constant for all the individuals, and which variable is different for individuals as well as different for different time. So that we can decide that which model we should apply in the panel data. This is one of the key important property of panel data. If you ignore this property, I can guarantee that you cannot select the right panel model for your data, because I have seen that many of the researchers, they are confused that why software is not giving me the output for this data, why, which model I should apply. And so this is if you want clarity that which kind of model you should apply for your data, you should know which variable is time invariant, which variable is individual invariant, and which variable is different for all the domains. So I hope now I am able to explain you the concept of different type of variables, and so that uh, in coming days when we discuss the different type of models, and when I say this is a time invariant model, so we cannot apply within effect, because this variable is a individual invariant model, so I cannot apply between effect. So I hope you will understand what I'm saying. So because PPT I already shared, so kindly tomorrow when we start the lecture, this point should be clear to everybody, because tomorrow I am going to discuss the application of different kind of variables in how to select model for them. Okay, so this is the formula. Basically, I already explained you the formula. Now, what I am saying is that the time invariant variables, like for example, if we have the time invariant variables like gender, education, I am saying that because for some person this variable may be constant with time. So they have zero within variation, because they do not vary over the time. Similarly, there are variables like individual invariant variables like time trend, economic performance, etc. They have zero between the variations, right? So they have between variation zero. Okay, so whenever you want to select the right panel data modeling for your data set, you must have clarity that which variable is my time invariant and which variable is my individual invariant. After that, if you understand the concept, the selection of the models will be very, very easy for you. Okay, now these are the advantages of the panel data, and we give the panel data is the only method which explains the heterogeneity of the cross-section units. It is having more information, and you can study the dynamics of change, means how the variable changes with time, and you are having the different effects, different options to find out the effects. Okay, now there are different softwares which are available for handling the panel data, and I selected Stata because Stata is the best software in dealing with the panel data. You may believe it or not. Panel data is Stata is the best software for dealing with the panel data. although you can use limbed up R, SAS, eViews, etc. And most of the researchers, I found that they are using the eViews, but they don't know eViews is having only selected models incorporated in the software. You can apply only those softwares. You cannot apply other softwares, other models. So eViews are having a lot of limitation in handling the panel data. So but in eViews we are having some more facility that you can apply panel co-integration, panel var very easily. We can also apply in Stata also, but in eViews we can run with more comfortable. Okay. Now, whenever we discuss on the panel data, so and I'm telling you that what we are going to discuss in this workshop. So just a basic concept I'm going to explain you that the first kind of model that we will study is the common constant model, which I will explain you just today. How to run the pooled OLS model or common constant model, pooled data model. So this is the basic type of modeling which we can do with the panel data. After that, we will go for a fixed effect model. In fixed effect model, we assume that the cross sections are heterogeneous and fixed effects are there. So in fixed effect, we are having different types. We are having the within effect, we are having the between effect, we are having the like effect with respect to intercept, or effect with respect to intercept and the slope coefficient. And we are having another feature also, like the effect of the time, effect of the cross section. So the one lecture is totally dedicated to the fixed effect model that I will take tomorrow. And after that, I will discuss the random effect model. And random effect model, the application of the random fact model, what is the assumptions of the random fact model, why we prefer random fact model over the fixed fact model. And then we will discuss the dynamic panel data model. In dynamic panel model, we are having two popular model, like Arellano bond model, Arellano Bohr model. And I will also discuss the panel unit root test, which we can conduct with the help of Stata. So this is the coverage of the workshop. Okay, and let me go to the, so these are the topics that I will cover in much detail, so I'm not discussing in the detail. Now rest of the things I am going you show you the Stata software, how to deal with the Stata softwares. So sometime I'm going to devote on that. Because most of you are new to the panel data, so I will be slow in dealing with the software part.